Hello and welcome everyone. Here we are to see some graph of trigonometric functions, especially the reciprocal function. We will start by cosecant. Cosecx or cosecant function is the same as 1 over sin x. So at everywhere when the sign becomes 0 will be undefined for cosecant. So those undefined points, look, the graph of sine function is plotted here by red color here. So where does the graph of sine function become 0? As you see at 0, pi, 2 pi, 3 pi, 4 pi. At this point, everywhere, it will be a vertical asymptote for cosecant. Because cosecant, we said it's 1 over sine x. It's going to be undefined point. So the graph of cosecant function will never cross those vertical lines. So the graph, how you can differentiate, here the graph of sine function is a downward parabola in this interval, but the graph of cosecant is going to be upward. In the second interval here, from pi to 2 pi, the graph of sine function is an upward parabola, but the graph of cosecant will be a downward parabola. So in that pattern, it goes, but the vertical asymptote should not be forgotten here. 0, pi, then from pi to 2 pi. But the graph from 0 to pi and from pi to 2 pi, it's not the same type. One upward, the other downward. But after that, it will repeat itself. Upward, downward, then again upward, down, so that the period will be 2 pi. So the general properties of cosecant function, general behavior, we can say. We are talking about cosec, don't forget that. First point, domain. The domain is the set of real number, but without those points, undefined point means the vertical asymptote, without n pi, for n an element of integer. At every pi, 2 pi, 3 pi, to the left also the same. Even at 0. So when you substitute 0 in place of n, it's going to be 0. So those n pi points are undefined points. So we need to exclude those points. So the domain is the set of real number without those points. The second point, range. When we are talking about range, the graph goes up and down without limit. But it starts from 1, it goes up, and down, it starts from -1. So the range from -infinity until -1 down, union from 1 to infinity. As I told you before, the upward parabola starts, the vertex starts at 1 here. All of them, when we are talking about the up part. When we are discussing about the down part, it starts from -1. It's moving down. So the range will be from -infinity to -1, union from 1 to infinity. The range of cosecant, remember. The other, period, the third point. Period, I tried to mention before, it is the same, 2 pi, like that of sine. And the fourth point, we can say, the fourth point, it has no x and y intercept. No x and y intercept. The other point, we can say it's neither increasing nor decreasing. Neither increasing nor decreasing. And the sixth point, we can say it is symmetric with respect to origin, because it's odd function. Sine is odd, so cosecant also odd function. The only even function is, it's from the 3, it is cosine. But the main points are domain, range, period, and x and y intercept. In case of cosecant function, you need to remember this sum behavior. Let us go to secant function. When you come to secant function, again, secant, it is 1 over cosine. So Secx is the same as 1 over cosx. So every point where cosine becomes 0 are undefined for sec. Cosine 0 point, first of all, try to observe the red here. The red curve here it is. Where are the zeros? The zeros are -pi over 2 and pi over 2, 3 over 2 pi, everywhere. So that now we need to get back and focus about cosec. general behavior. By the way, we said like before, we said that for like that of the sine function, here it is a downward parabola between negative pi over 2 and pi over 2. And between pi over 2 and 3 over 2 pi, it's an upward parabola. So where the cosine become downward parabola, the sec will be an upward. And when the cosine become an upward parabola, the sec graph will be downward parabola. But those interval, like the bit between pi over 2 and 3 over 2 pi, okay, the interval, in this interval, there will be asymptote here, because the 0 points of the cosine are undefined point for secant. So the general behavior, let us start to mention those general behaviors. First, domain. The domain is again a real number, but without what? Without those 0 points. What are they? We can say it is n over 2 pi. What's n? N is an element of odd integers. 1 over 2 pi, 3 over 2 pi, 5 over 2 pi, everywhere. To the left also, negative 1 over 2 pi. Those points are the 0 points of cosine. So these are undefined points. Those are excluded. The excluded points, by the way, everywhere these are vertical asymptote. The same manner what we said before here for cosine, those excluded points are undefined points, so that they are vertical asymptotes. Range. The same. By the way, cosine function, the range is between negative 1 and 1, like that of sine. So second, range from negative infinity to negative 1, union from 1 to infinity. And the third point, period. The period is 2 pi. It will repeat itself after 2 pi. Between, for example, from negative pi over 2 until pi over 2, it's an upward. And again from pi over 2, 3 over 2 pi, it will be a downward. Then after that, it will be an upward. So one cycle means from negative pi over 2 until 3 over 2 pi. If you subtract, you will get 2 pi. So the period will be like that of cosine. It will repeat itself. For the point here, it has y-intercept, but no x-intercept. Number 4, y-intercept, it is at 0, 1, but no x-intercept. These are some points that you need to remember about sec. But in general, when you are trying to study the graph of secant function, first you need to recall the graph of cosine. The graph of cosine the graph of cosine is there, means you can sketch easily the graph of secant, because the 0 points are asymptotes. So downward parabola for cos means upward for sec. The same manner for cosecant. So these are the two reciprocal trigonometric function graphs and their behavior. Let us go to cotangent. Okay, when we see the graph of cotangent, we need to see the graph of tangent together at the same time. First of all, tan x is the same as sin x over cos x. So that all points where cosine becomes 0 are undefined for tangent. So what are those points? As you see here in the graph, negative pi over 2, pi over 2, we said before. So the domain of tangent functions are real number without n over 2 pi. What's n? N is an element of odd integer. So now our objective and our focus is not tan, it's cot. So Cotx, it is the same as cosx over sin x. So the point where sin x becomes 0 are undefined point for cot. Those are vertical asymptotes. So where are they? Sine becomes 0 at n pi in general. So that the domain of cotangent, we are talking about cotangent function behavior. Here behavior, the domain will be real number but without n pi for n an element of integer, like as you see here, 0, pi, 2 pi. Those are undefined points and vertical asymptote points. That is the first point. What about the range? The range is a set of real number. Y an element of real number, we can see. The same for tangent, by the way. As you see, both of the graph, they are moving up and down without any limit. So that the range of tangent and cotangent graph, it is a set of real number. Number 3, period. The period is just pi, like that of tangent. Tangent period is pi. So the cotangent also the period, which will be pi, because every pi interval the same pattern. Look, from 0, for example, let us use black marker here. From 0 to pi, it's a kind of curve. The same curve happen between pi and 2 pi everywhere. Again, look the graph of tan also. Between negative pi over 2 and pi over 2, there is an increasing curve here, up to the right, down to the left. The same from pi over 2 to 3 over 2 pi, it's up to the right, down to the left, the same pattern. But this one, it's decreasing from 0 to pi, up to the left and down to the right. That means it's decreasing graph. So number 4, behavior number 4, we can say it's decreasing. Tangent, it was increasing, but cotangent, it is decreasing. And number 5, it has x-intercept, by the way. What are the x-intercepts? Every n over 2 pi. The x-intercepts at x is equal to n over 2 pi. What's n? Again, n is odd integer. At every n over 2 pi, it crosses the x-axis, but it has no y-intercept. No y-intercept. But the tangent graph, it crosses the y-axis at 0. But the cotangent, it will not cross the y-axis. So try to observe from the graph of tangent and cotangent, there is some similarities. The similarity is the tangent, for example, the range for both set of real number, and the period for both it's pi. But the undefined point, or the asymptotes, or the domain which are excluded points, will be for tangent and cotangent different. The reason, because tangent, the denominator is cosine. So the cosine 0 points are undefined or vertical asymptote for tangent. But when we are discussing about cotangent, the domain points are real number, but without the 0 points of sine. The sine 0 points are n pi in general. So that those points are vertical asymptote. So these are some general behavior and properties of cotangent function. Try to remember, like try to visualize how does it looks, and the general behavior of sine, cosine, and tangent, then the others will come. So thank you for watching. I'll come back with trigonometric identities video. Don't forget to subscribe. Thank you.